For this project, we chose the topic of the law of conservation of momentum. Momentum refers to the quantity of motion that an object has. If an object is in motion, then it has momentum. Momentum is represented by the equation mass times velocity. Momentum is represented by the lowercase letter p. The units for mass are kilograms, and the units for velocity are meters per second. Therefore, the units for p are kilograms times meters per second. There are two types of collisions, elastic and inelastic. Elastic collisions are when two objects collide and bounce off each other. An inelastic collision is where two objects collide and stick to each other.
René Descartes formulated momentum when he was living in Holland. He was looking for a way to mathematically describe how objects move. He began with the idea that motion was a conserved property of the universe. He used collisions to test that idea. The first mathematical expression was the product of mass and speed. This seemed to work well for elastic collisions, but failed utterly in inelastic collisions. A student of his offered an observation, and Descartes used it to add a directional aspect to speed. In other words, Descartes tried the product of mass and velocity, only to find that it worked well.
Newton took Descartes' work further, and from it he developed his laws of motion. Add those laws together, and it produces the law of conservation of momentum.
This is a perfect example of the law of conservation of momentum for an elastic collision. When one ball is pulled back and let go, and strikes the rest, only one ball bounces off. But when two are pulled back and let go, two bounce off, showing that the law of conservation of momentum exists.
This is a table used to show an example of an inelastic collision. Before a collision, car 1 has a momentum of 50 kilograms meters per second. Car 2 has a momentum of 0 kilograms meters per second. So the total system momentum is 50 kilograms meters per second. After the collision, car 1 has a momentum of 25 kilograms meters per second. And car 2 also has a momentum of 25 kilograms meters per second. So the total system momentum is 50 kilograms meters per second. This shows how momentum is conserved in a system.
When a collision occurs between two objects in an isolated system, the momentum before the collision is equal to the momentum after the collision. So that means that the momentum lost by object 1 is equal to the momentum gained in object 2. So when object 1 collides with object 2, the momentum of object 1 and object 2 combined are equal to the total system momentum.
This was our first trial of an inelastic collision. Car 1 has a mass of 0.25 kilograms and car 2 has a mass of 0.25 kilograms.
For trial 1, the mass was 0.25 kilograms and the velocity was 0.68 meters per second. The momentum was 0.17 kilograms times meters per second. When they collided, the combined mass was 0.5 kilograms, the velocity was 0.34 meters per second, and the momentum was 0.17 kilograms times meters per second.
This is our second trial, in which we added 5.25 kilogram masses in order to bring the mass of car 1 up to a total of 1.5 kilograms. In trial 2, we increased the mass of car 1 to 1.5 kilograms. The velocity was 0.6 meters per second, so the momentum was 0.9 kilograms meters per second. After the collision, the total system momentum was also 0.9 kilograms meters per second. Because the mass of the cars together was 1.75 and the velocity was 0.52. We then added 5 more 0.25 kilogram weights, bringing the total mass of car 1 to 2.75 kilograms. In trial 3, we added mass to car 1 and made the total mass 2.75 kilograms. The velocity was 0.704 meters per second, so the momentum was 1.9 kilograms meters per second. After the collision, the total mass was 3 kilograms and the velocity was 0.64, which also gave us a momentum of 1.9 kilograms meters per second.
So the first thing we did was we started out with 2 cars, both weighing the same thing, and what we did was we collided them, and we did this 10 times, and each time we did it, we'd add 0.25 kilograms. We did this a total of 10 times, so the lowest mass that we added was 0.25 kilograms, and the highest was 2.5. We collided the cars and recorded the results, and we multiplied the mass and the velocity, and it equals the momentum. Therefore, momentum was conserved.
We graphed our data and found that momentum 1 was directly proportional to momentum 2. From looking at the graph, you would think that the equation would be momentum 2 equals 1 times momentum 1. But look at what we actually got as our result. The equation we got was momentum 2 equals 0.9925 kilograms times meters per second times momentum 1. The reason that it is 0.9925 kilograms times meters per second instead of just 1 probably comes from some problems when we collected data. Sometimes there's friction or other forces that cause the law of momentum of conservation to not be 100% accurate if there's something interfering. Thanks for watching our project.